So we're going to be looking at algebraic proofs now. And what we've done with algebraic proofs is we're actually going to go ahead and do things that you've done before, which is solving algebraic equations, but now we're going to actually prove it and formulate the logic behind it using these particular types of these particular theorems. So what we're going to do first is, let me see if I can change the shadow just a bit. Okay. So what we're going to do first is we're going to look at these properties. This is the first part. I'm going to explain all these properties to you in the first video, and then we're going to get rolling with some examples. So the first one says the addition property of equality. That's the addition property of equality, and that says if A equals B, then A plus C equals B plus C. What that means is on the addition property of equality, if you add something to one side of an equation, you must add it to the other. And when you do that, the equation will stay equal. So let me give you an example. If I have x equals 7, and I want to add 2 to one side, I've got to add 2 to the other. So that then says that I can say that x plus 2 must equal 7 plus 2, which is 9. That's the addition property of equality. I've added 2 to each side. Similarly, what you'll see when we get to the proofs is you'll see something like this. You'll have x minus 4 equals 12, and I need to move the 4 over, so I use the addition property, which says if I add the same thing to both sides, I maintain the integrity of my equation. So that means that now to move from here to here, to go from there to there, I added and used the addition property of equality to manipulate the equation to get my x where I needed it to. I added to both sides. So that's the addition property of equality. So now let's look at subtraction. The subtraction property of equality is the same thing. Okay. So the subtraction property is the same thing. So what we're going to look at is instead of adding, we're subtracting. And again, I'm going to use the example that you'll see down here. Let's say you have x plus 14 equals 19. How would you solve that? Well, you guys know, you've been programmed like robots. Oh, subtract 14 from both sides. Well, you know that, but you don't know what that's called. That's called the subtraction property of equality, which means if you do something to one side of the equation, you can do it to the other, and that keeps the equation working. So now that x equals 5. You've just used the subtraction property of equality to go from this equation to this equation. Okay? Let's look at the multiplication property of equality. The multiplication property of equality says the same thing, except now I'm going to be multiplying. And let me underline these so you can see and match up the colors a little more easily. Oops. So now you can see the colors as I go when I'm explaining them. So let's look at the multiplication property. It says if A equals B, then A times C equals B times C. So basically, here's some examples. If x equals 4, that means if I multiply 3 on this side, I have to multiply 3 on this side, so that means that x equals 3x equals 12. So to get from here to here, I multiplied both sides. That's multiplication. Here's where you will see it in proofs. If I have 2/3 x equals, let's say, 8. What do we usually do to get rid of a fraction? We multiply both sides by the reciprocal. So I will use the multiplication property of equality to get rid of the 2/3. This is where you will see it commonly in your proofs. So that cancels and that reduces, so I get x equals 8/3, 8 times 3/2, which would be 24 over 2, which is 12. So to get from this equation to that equation, I multiplied by 3/2. So that's the multiplication property. You can kind of see the pattern here. They're each saying that if you do something to one side of the equation, you need to do it to the other. And that will work. And that will maintain the integrity of the equation. It will still be good. So now let's look at division. Division property is the same thing you just did, except now it says if A equals B, we can divide both sides. You see this one more common than anything else. If I have 4x equals 24, and I want to solve that, what am I going to use? Division. And what am I going to do? Divide both sides. So that gives me x equals 6. You just use the division property to go from this equation down to this one. So anytime you see a proof and it's you go from here to here, the reasoning is the division property of equality. So that's the division property. All right, so let's keep on moving. And let's look at the distributive property. You guys should be, and this is a property of multiplication over addition or subtraction. So when you distribute, you're going to take the coefficient of the parentheses and you're going to distribute that value to each number inside. So for addition, A times B plus C equals AB times AC. You've distributed, you've multiplied the A times the B to get AB and A times positive C to get AC. For subtraction, you multiplied A times B to get AB and A times negative C to get negative AC. So all you're doing is distributing out. When would you see this algebraically? You might see something like this. 3 times x plus 2, and you would distribute. So that would become 3x plus 6. If you want to use subtraction, let's do 3 times x minus 4. 3 times x is 3x. 3 times negative 4 is negative 12. So that's how you use the distributive property. All right, so let's look at substitution. So now we're looking at the substitution property. Substitution is when you put something of equal value in for something else. So it says if A and B are equal, then B can be substituted for A in any equation. Now exactly what does that mean? Well, let's do something like this. Let's say x equals 2y, and let's say 3y minus 4 equals 11. Substitution says, what do I know x is, I'll make this an x. Let's rewrite that. 3x minus 4 equals 11. Substitution says I can plug in something that's equal. Well, what is x equal to? 2y. That means anywhere in this equation that I see an x, I can plug in 2y. That is substitution. I've substituted one value in for another that's of equal value. Okay? All right, so moving along. Let's look at the reflexive property. Reflexive is right here. Okay? Reflexive, for any number, A equals A. Okay? That's a simple property. That's one that we call kind of almost a common sense property. Let me try to adjust this a little bit better. Okay. It's a common sense property. So with the reflexive property, what you're going to see is you're going to see basically any number is always going to be equal to itself. And yes, it's necessary to have that. We will use that when we get into figures, especially congruent figures. So if A is always equal to A, that's all you have to know. Okay, so now let's look at the symmetric property. Okay, so now we're looking at symmetric. The symmetric property says if A equals B, then B equals A. Basically what the symmetric property says is you can switch things on the side of the equal sign. It doesn't matter what side they're on. I can say x plus 7 equals 9, or I can say 9 equals x plus 7. It doesn't matter if the x plus 7 is on the left or the right. If I've got two equal values, I can put them anywhere. Here's another example. I can say 6 equals 3 plus 3, or I can say 3 plus 3 equals 6. It does not matter which side of the equal sign they're on. And that's the symmetric property. Okay? You think of a law of symmetry. Symmetry is when you can divide something right down the middle and it has two equal halves. Okay? So that's the law of symmetry. If I were to put these right next to each other, if you look like, it actually looks like symmetrical. This is a mirror image of this. Okay? They're symmetrical. A equals B, then B equals A. If x plus 7 equals 9, then 9 equals x plus 7. All right, the last one is the transitive property, and we used that when we did law of syllogism. So let me find one more pin here. Get a little bit more creative. So we've got the transitive property. Transitive is what we did with law of syllogism. If A is equal to B, and B is also equal to C, then it holds true that these two guys should be equal to each other because they're equal to the same thing. So, for example, if x plus 2 equals 8, okay, if x plus 2 equals 8, and 8 equals 4 plus 4, then we can say that x plus 2 must be equal to 4 plus 4 because they're both equal to 8. And those are your algebraic properties of equality.